Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to this class again, and today we are going to be treating vectors and scalars. By the end of this lesson, you should be able to differentiate between vectors and scalars. And then the second is be able to represent vectors. And then the third one is explain and apply resolution of vectors. When you see something that happens like this, a body is pulled on a horizontal table, what do you think that happened? Whenever there is a motion, you know that a force is applied. And this is one kind of it where force is applied. And also in this case, you see that there is a force applied on a body. Now, is this lesson all about force? No. What we are going to be treating is a physical quantity which is called vector. Now, the definition of a vector is that vector is defined as any quantity that has both magnitude and direction. It has both magnitude and direction. While when we talk about scalars, we are talking about a quantity that has only magnitude, but it does not have direction. Example. Now, let me take you back to this. When you look at this diagram, you are seeing that there is a direction in which this body on this table is pulled. And there is a magnitude in number. When we talk about magnitude, we are talking about size of a quantity. So what force was needed to pull this body is about 1 Newton was needed to pull this body, and it moves with a uniform velocity on the table. That kind of quantity that has both the magnitude and direction, we represent them as vectors. Even this one is a force pushing this particular body on a given direction. Now, if you follow this lesson on when we treated physical quantities and the proof of those quantities or unit of a body, you will now come to the point where we talked about types of physical quantity. And that brings us exactly to a little recap of what we did in that lesson. When we say that a quantity represented by let's say 50 Newton. This one is talking about what? This is a scalar. This is a scalar quantity. When you say that a body is 50 Newton, you are talking about the scalar quantity. And you say that maybe let's say 50 degrees Celsius, you are talking about scalar. But what happens, what makes it a vector? When you say that, at that point, what I mean is, I'm removing this Newton, let's say 50 meters. If you say 50 meters, you are talking about speed. It's not a vector. If you also say 50 degrees Celsius, you are talking about temperature. It's not a vector. But if you say 50 meters due, let's say east, or you say due west, or you say due north, or due south, what have you done? You are giving a direction to this magnitude. This is the magnitude in meters. That means you are talking about distance. But once you put direction, you are calling a displacement, because it's what a vector quantity is interested in. A vector quantity is interested in the number of a quantity or the value of a quantity and the direction that the quantity is taking. That is what vector is talking about. The same thing about this temperature is a scalar quantity. That is, you have never heard where we say that the temperature of a body is due north of the body or due south of the body. No, therefore it makes it a scalar quantity. Whenever we talk about force, like the one you are watching on the screen, there must be a direction of force, and that makes it a vector. In general and in totality, when we are talking about vectors and scalars, we are talking about a quantity, a measurable quantity that has direction, that is for vector, and when it does not have direction, then you call it a scalar. Now, vector representation, whenever you want to represent vector, you consider the length of the arrow, tells you the magnitude, that is in terms of scalar. Let me show you. Now, if you have this arrow, if you put this arrow, say 50 meters, everybody must know that what you are talking about is a vector. Look at this one now is for 50, right? Now, when you draw it this way and put arrow, I should expect you to write something above 50 because the line is already bigger than 50. So that is what we are looking at. From the tail to the head of the arrow, you have a magnitude. So the length of the arrow, even if it may not be drawn to scale, represents the magnitude, but the arrow tells you about the direction. So when you want to represent a vector, make sure you put arrow, and when you write a straight line, put arrow to show that it is a vector. Or if you don't want to put that, you may remove this and say A. That means vector A with the arrow. You must put that. Sometimes they write it A with a cap to represent a vector. So vector quantity is represented with this arrow or this kind of representation. Anywhere you see it with a body with arrow, you know it is a vector. But listen, sometimes they will write something like this. This is not a vector because there is no arrow representing the direction. So each time you see that, you know it is all about a scalar quantity, all right? Now, here brings us to a very important aspect, which is called resolution of vectors. You see, let me take you back a little to this part. You see this? Anytime you see a body moving round, moving on a body, or a body moving on a table like you are seeing on the screen, something is happening. There are two forces that are acting on this body. One is the weight and one is this force. Look at this. This is that particular body you are watching on your screen now. This is the weight. The weight is moving in this direction. Remember, I put arrow to show that it's a vector. And there is another force applied on this direction. FP, mostly called applied force. And then it is a kg, that means it has a mass. So what happens? These are two forces acting on a body. But at the end, irrespective of the weight of the body, the force pulling this body was able to take it away. So we are talking about what is the result, what is the resultant of the force that was able to overcome the weight of the body, overcome the resistance of the body, and the body was able to move with a given velocity. Whatever that force is giving us a resultant force or resultant vector. Let me give you another example. Look at this thing you're watching on the screen, the diagram you're watching on the screen. Assuming this is still a body and somebody is pushing in this direction, let me say that a heavy man, I mean a man that has power of, let's say, it's not power, I'm not using power, power is a scalar. A man that has a heavy force, let's say the man has 800 Newton. And then another man has, let's say, 200 Newton. And they are pushing this body, this heavy load. What do you think will happen? This load will move faster because this man is moving in this direction and the force of this man is also moving in this direction. There is going to be a combined force on this body and the two of them are going to make it to move faster. Imagine this man, this force was not applied. What will happen? This man is still going to move it, but it's not going to move as fast as when the 200 Newton was applied. So what am I saying in essence? What I'm saying is that imagine another man comes here and then applies 700 Newton. in opposite direction, what is happening? This man is bringing a resistance. This man is not going to move as fast as it would have gone when there is no opposition. So what will happen? This man will still move in this direction, but the resultant force is going to be 100 Newton, because 800 minus 700 is going to be, so the resultant force, that is the result of the whole forces acting on the body, the end product of the force is going to be 100 Newton. We apply these things in everyday life, and it's just that sometimes it's difficult for us to bring them to the explanation on what's happening in physics. Now that takes us to the first case of resolution of forces. The first is when the forces are acting in the same direction. Now, before I also go that, a resultant force is that a simple force or vector, resultant vector. So look at this. When they are moving in the same direction, what do? You all have to say that 80 plus 7 Newton is going to be 87. So the resultant at that case is going to be 80 plus 7 is going to be 87 Newton. That is the resultant vector or the resultant force that will be used to push this mass, this body of mass 50 kg in that given direction. Now, case 2. Now look at what happened. A man of, let's say, a force of 10 Newton is pushing in the east direction, and then another one of 7 Newton is pushing in the opposite direction. What will be the resultant? When the direction is opposite, we are going to apply what we call negative, that is subtraction. So the resultant is going to be the bigger vector minus the smaller vector, because the bigger vector or the bigger force is where the body is going to move. The body is going to move also in that direction, but it's going to be 10 minus 7. The resultant is 3 Newton. Now, before we talk about what happens when they are not going to be applied in the same or opposite direction, we have a situation. Let me show you something that happens here. Look at this. You see this? Two forces, they are not acting in opposite direction. They are not acting in the same direction, but they are acting at an angle to each other. That means this one is applying at an angle of 90 degrees with each other. Now, I want to first of all introduce this principle called triangle and parallelogram law. Whenever you talk about triangular law or parallelogram law, we are talking about the law of finding the resultant of a force or a vector when two forces are involved. I said two forces, it must not be more than two. We apply triangular law or parallelogram law. Now, first of all, what parallelogram law stated? Let's look at it. I'm going to explain what this whole thing is stating, then before we talk about reading it out. First of all, assuming you have a body, let me use this body, maybe a ball of 50 kg or whatever, then a force of, let's say, 7 Newton is applied on this northeast direction, and another force is applying it on this direction. Remember, this is longer, it's going to be, let's say, 10 Newton. Now, what happens? We have formed two kinds of lines. Now, what is the resultant? But remember, there must be an angle, theta. What is the resultant? How to find this resultant? If I'm to solve this now, what I'm going to do is I'm going to draw a straight line, call it resultant. I'm going to now complete this diagram to form a parallelogram. Remember, what I'm explaining is parallelogram law. I'm going to join this part. I'm going to use a broken line. This line I have done represents from this point A to put this point B. So I have done this. Remember that parallelogram 1 is longer. So this is this place. So this side and this side are the same. Now what happened? From A to C, let me call this place C. I'm going to join another one which is representing this 7 Newton. And I'm going to put it this way. Now, you see that? So I have completed a parallelogram. Then what is the resultant? The resultant is going to be a line joined from the point of the starting to the point of the end. Let me call it D. So this is going to be the resultant. This is going to be the resultant. Now, a little geometry. A little geometry is going to tell you that since these two sides of a parallelogram are parallel, the angle here from here to here, which is theta, is going to be angle at this point, theta. So what is going to be here now? This is going to be 180 minus theta. And this, if I return this, 7 is going to be here also. This is 7 Newton. From here to here is 10 Newton. So if I want to break this down, I'm going to do this. I'm going to have 7 Newton, 10 Newton, and this angle is 180 minus theta, and this is the resultant. I will call A, D, and B. This is what parallelogram law stated. Now look at what it stated. As I am going to be reading it, I will be explaining with this. He said, parallelogram law of vectors states that if the two vectors are represented in magnitude and direction, look at this, two vectors, the first one is 10 Newton, second one is 7 Newton. They are represented in magnitude, which is 10, and the direction in the east. This is magnitude, which is 7 Newton, direction is northeast. By magnitude and direction, by the adjacent side of a parallelogram, adjacent, this side and this side, they are adjacent. Now, what is the diagonal? Look at this. The diagonal drawn, the diagonal is a line, transversal line, which is neither vertical or horizontal. It's a diagonal. That is this line. So the diagonal drawn from the point of intersection. Where is the point of intersection? The origin at this point, A, is the point where vector 7 and vector 10 intersected. So the line drawn from this point all the way to the end represents the resultant vector in magnitude and in direction. And that is what parallelogram law stated. And with this, we can now apply what is called cosine rule in solving from A to D. And that is what the resultant vector is representing. Now, when we talk about triangular law, how does that work? Look at triangular law. When we talk about triangular law, we are talking about, let me remove this. When we are talking about triangular law, it's simple. When you have a question, two questions or three forces. The third force in this point may represent the weight of the body. But then what triangular law is saying that if you have a vector in this direction and then you have another vector here, so how do you form? You use these two, let's say 7 Newton and 10 Newton. You use these two to form a triangle. That's all. But how do you do that? First of all, draw the first one, which is 7 Newton. Then this is the head. This is the head and this is the tail. Carry the second one and place at the head of the first. Now, carry the tail of the second one, place at the head of the first. So I'm going to do it like this. 10 Newton. Then, this is the starting point. Once you join the line from the beginning to the end, you have formed a triangle, which is called triangular law, which is you are using two vectors, including the resultant vector, to form a whole triangle. That is exactly what the triangular law is talking about. We are going to be applying them in problem solving. Now, remember all these I'm explaining talks about just resultant or resolution of vectors when two forces are involved and those two forces are represented in angle to each other. Now, let's apply these principles in problem solving. Look at this question. At an angle 90 degrees to each other, what do you do? Let us use parallelogram law of vectors to solve this. I can also use triangular law to solve it, but let me use parallelogram law and see what happens, how I'm going to represent it and be able to find the resultant. If I'm asked to find the resultant, I'm going to have, this is the first one, which is 3 Newton, and this is the second one, which is the 4 Newton, and the angle 90 to each other, all right? So what does parallelogram law stated? It says that when two vectors are represented in magnitude and direction by the adjacent side that the diagonal drawn from the point of intersection to the other represents the resultant in magnitude and in direction. So I'm going to draw a line here, call it resultant. Now I'm going to complete the parallelogram. This point A to point B, I'm going to represent it here, which is going to be the opposite for a parallelogram. Not be use broken lines. All right, this is also representing 4 Newton, because remember, opposite sides of a parallelogram must be the same. And I'm also going to use a dotted line here to represent here, which is 3 Newton. All right, now you see I have completed it from here to here and from here to here. This is angle 90. Now at this point, what do you notice? You notice that I have a kind of triangle called right angle triangle. And when you have a right angle triangle, the only rule in the life of mathematics for you to solve a question on a right angle triangle is to apply Pythagoras theorem or trigonometric ratios. For the sake of this problem, look at this. If I remove this part, I have a right angle triangle, and you are asked to find the resultant. R square is going to be, that is the hypotenuse, is going to be equal to 4 square plus 3 square. The resultant is going to be 16 plus 9, which is equal to 25, which is 5 Newton. So that resultant vector, the end, look at this thing. When I talk about the resultant vector here, I mean irrespective of this one is pushing upward and this one is pushing sideward, that the effect of the two of them, what they have achieved on this body, is a force of 5 Newton. And that is the resultant. That is the resultant effect on this body, on the motion of the body. That is the force combined to be able to cause a motion or change of position of these bars of the body. Now let's move further. The process of resolving a vector into each component requires the effective component of vectors along this and that. Now, I'm going to another kind of resolution. Remember, the next kind of resolution of vector is going to be more than 3. I have talked about when they are 2 opposite, when they are moving in the same direction. So what if different forces are applying on the body, like you are seeing now? Different forces applying on the body. How are we going to solve it? You also have this kind of problem. We are going to now use what is called the resolution of vectors of Moore. In that case, we are still going to apply the same principle. But before I do that, I want to show you how to resolve one vector at an angle. A lot of people have come up with different formula, Lami's triangle and whatever. But let me show you this. If you have a body, let's say F, force applying on a body at an angle 30 degrees. What is going to be the effective force on this body? The effective force is going to be either the one on the vertical axis, which is called the vertical component of this force, or the horizontal component of this force. How do you achieve Fy and the Fx? You can only resolve a singular force. Remember, all these ones I've been telling you about resolution of forces. I've been talking about 2 forces or more forces. But now I'm talking about only one force, especially like the children do, they will tie a rope to a rubber and start pulling it. At that case, at an angle, when it is pulled at an angle, what is the effective force that will bring about a motion on the body? We say it is effective force. They will have what is called vertical component. Vertical component, which is called Fy. And this is called the effective force on the vertical. We also have another effective force, which is called horizontal component. And which is given as Fx. You see? So when one force is applied on the body, you resolve it into vertically and horizontally, provided there is an angle given for it. And that principle is what I'm going to achieve in solving this problem. All right. I'm going to resolve each vector vertically and horizontally. Look at the problem. At this point, I'm giving it 50 degrees, and the force on that body is 12 Newton. Then this is another one, 40 degrees at an angle, 20 Newton. And this one is 16 Newton. And there is a force, another one here. Let me say this is 30 degrees at a force of 15 Newton. How are you going to resolve this? This is no longer the one we learned. But however, I am going to resolve one of these into vertically and horizontally. I'm going to resolve this into vertically and horizontally. I resolve it into vertically and horizontally. After that, then I will be able to break it into opposite forces. Let's start with this one. I'm going to make a projection of this vector on the vertical axis, which is negative f. I'm also going to make a projection on this one, which is positive x. I'm going to make a projection of this one on this side, which is going to be negative y. All right. If I find fy, this one is also fy. And then this is going, anything on the horizontal is going to be fx. So I'm going to resolve. When I take opposite over hypotenuse, it's going to be sine. So this is going to be 20 sine 40 on this vertical component. I have resolved this one to vertical. I'm resolving it to horizontal. It's going to be 20 cos 40 on the horizontal. I'm resolving this one into vertically and horizontally. This is opposite over hypotenuse. And this is going to be plus, because this one is going to join this one in the vertical component. It's going to be 12 sine 50 degrees. Remember, I'm using trigonometric ratios. And because if you check this one, it's going to be opposite over hypotenuse. And whenever you say opposite over hypotenuse, we are talking about SOHCAHTOA. So you can also go and revise more on that principle. So when you have opposite on hypotenuse, you have sine. And that is why I have 12 sine 50. So I'm going to resolve this also to the horizontally. When I resolve this horizontally, it's going to be on this, it's going to be 12 cos 50. All right, I'm done with that. If I resolve this, all right, I'm not going to project it to this vertical. I'm going to project it to the horizontal. Remember, 16 Newton is already here because that is the direction of the force. If I resolve this to the horizontal, I'm going to have this. I'm projecting it here. And that is going to be Fy, and this is Fx. And this is going to be opposite over hypotenuse, because this is 15 Newton. Opposite over hypotenuse. And that is going to be sine. So I'm going to say plus 15 sine 30. So when I resolve this with respect to the horizontal axis, I'm going to have adjacent over hypotenuse. Sorry, there is one I have to do here. It's not that one. This one is going to be, if I'm considering Fy, I'm talking about the horizontal. So it's going to be plus 15 sine 30. So when I consider Fx, which is going to be horizontal, it's going to be 15 cos 30. All right. Okay, let's take out this one. All right. We have to bring them all back. Remember, we have everything recorded in y-axis, this one, and this one. So we are going to record the forces that happen when we finish resolving them vertically and horizontally. Now I have, this one is, everything on the vertical gave me 22.05, and on this part we have 15.3, on this part we have 30.7, on this I have 23.5, all right? So see what I mean? When you resolve, remember we resolve this one vertically and horizontally. So when you do that, you record all of them and add everything that came to the horizontal axis, add all that came to the vertical, and when we did that, these are the forces we had. Now, if you consider this very well now, you realize that for me to be able to find the resultant, we know that this force and this force, which one is bigger? 23 is bigger. Therefore, the force is going to go in the direction of the bigger force. The movement of the body is going to go in the direction of the bigger force. And this one is bigger, is going to go in the bigger force. So what do I do? In order to be able to have two forces before we apply the parallelogram law of vectors, I have to take the net force between this and this. 23.5 minus 22.05 is going to be 5, and this is 4.1. So this is going to be 1.45 Newton on this direction, in this direction. Then we're also going to take 30 minus 15, 30.7 minus 15.3, this is 4.5. So this is going to be 25.4, 25.4 Newton. All right, when I do this, I'm going to remove this and now use only these two, because the whole of these forces have been resolved into horizontal and vertical. So I'm going, in order to find the resultant vector, I'm going to apply the Pythagoras theorem, because at this point is applied at angle 90 degrees to each other. So I'm going to say 1.45 all squared plus 25.4 all squared. That is the concept of finding the resultant. So I'm having 1.45 raised to power 2. We are having 2.10 plus 25.4 squared. I'm having 645.2. So the resultant of this body is taking adding them. So this is going to be, if I have 645.2 and then this is 2.10, so this is 3.746. I'm going to have take the square root of this. So the square root of 647.30. The resultant is going to be 25.44. The resultant is 25.44 in Newton. This is the resultant of this vector. You just need to pay keen attention, and if there is any step you miss, you can check back. And thank you. We have come to the end of this lesson. But before we go, we are going to take a few more exercises from the UTME ExamGuide app. Okay, we're already here. Let's look at a few questions we are going to solve here. Let's solve this question. The diagram above shows forces on this. We have to find the point O, the direction indicated, the net horizontal force. Yes, the net horizontal force. Now, if you look at this, like we just said, I'm going to resolve this horizontally and resolve this horizontally because I'm only interested in the horizontal forces. So how do I do that? What? This one is 4 Newton in this direction. So this one is 60 degrees and 8 Newton is applying to that direction. This is 6 Newton and 60 degrees. I'm going to complete this triangle. I'm going to call this one Fx. No. This is Fx. That is adjacent over hypotenuse. And also this one. If I complete this one, it's also going to be adjacent over hypotenuse. So what is going to happen there is, this is this line I'm going to have. If I have 8 cos 60, I'm going to have 8 cos 60 plus 6 cos 60. And this direction is 4 Newton. What I did is simple. Let me explain better. At this point, this is 8 Newton and this is 60 Newton. I'm looking for Fx. What is this Fx? Fx is the horizontal component of 8 Newton. If I complete this, a triangle, doing a projection of a vector on the horizontal axis, I'm going to have that adjacent, which is the horizontal component, and the hypotenuse. So according to SOH-CA2A, SOH means I'm using K because this is adjacent and this is hypotenuse. Cos 60 is equal to, adjacent is Fx all over, hypotenuse is 8. If I clear the fraction, I have that Fx is going to be 8 cos 60 degrees. You see? So that is what I did for 8 Newton and I got 8 cos 60. I will also do it on this 6 Newton. I will also have 6 cos 60. Now I'm going to have 8 cos 60 plus 6 cos 60 for me to have a total of the forces acting on this direction, and 4 Newton is already acting on this direction. We can now take the resultant of the forces. But remember, the question is giving me in surd form. I'm going to find what 60 is in the surd form, and I'm going to apply this principle. I'm going to go back to this special angle proof, which says that if this place is 60, this is 2, 1 root 3. Now, cos is adjacent of hypotenuse. So, cos 60 is, from this thing I have done, cos 60 is going to be 1 over 2, which is 0.5. Therefore, that is adjacent over hypotenuse from this. This is an equilateral triangle. All right, I have 0.5 times 4 is going to be 4. 0.5 times 8 is going to be 4. And this one is going to be 0.5 times 6 is going to be 3. So everything here is going to be 7. So 7 minus 4 is going to be 3 Newton. Okay. There is 10 there. I was like, there is 10 here. So that 10, I'm going to add it 10, it becomes 17. So 7 plus 10 is going to be 17. Totally 17 at that point. So now, in order to be able to find the horizontal force, 17 minus 4 is going to give you 13 Newton. And 13 is there. Option D is 13. Now, look at this question. They say that if the angle between two vectors, P and Q, is 0, the vectors are said to be perpendicular? No. They are going to be parallel. When the angle between two vectors is 0, that means we said that the angles are parallel, and that is option B. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.